Hey, what's up everybody? Welcome back to another Layer by Layer. In today's tutorial, we're going to take a look at using sheet metal tools inside of Fusion 360 to make enclosures out of paper, or chipboard in this case, to make enclosures for your electronics. So here I have a little paper box that is fully assembled using the sheet metal tools inside of Fusion 360. I have a couple of components here. I got my Circuit Playground Express that's mounted on top, and I have a micro servo mounted on the side. And then in the inside of the box, I could fit things like the battery or wires and things. So what's pretty cool about this is that you can unfold this design and export it out as a flat pattern for cutting on vinyl cutters, like the Cricut machines. So let's take a look at that. I'm going to switch over to the sheet metal tool, and I'm going to activate my flat pattern. And what you'll see is Fusion will go ahead and unflatten. It'll take the box and turn it into a flat pattern, so we can export this out as a vector, as a Dxf file. And then we can bring that into our software for cutting this template out of chipboard. Chipboard is a material that's made out of paper, but it's thick enough to do sort of 3D dimensional boxes or even paper crafts. So it's really cool. So I'm gonna hit exit flat, and then it kind of brings it all together. So it's really nice. This box is actually one piece, and it has a little sort of tab insert that gets slotted in here, and it kind of just secures itself. It's a nice little housing for electronics, and when you can cut it out of paper, it makes it a lot more easier than having to do something like 3D printing or CNC milling. So that's really cool. So let's take a look at how we can design a box inside of Fusion 360. So I'll make a new design, and what I'll do is I like to use my grid just to kind of see where I am in space. So there's my grid, there's my floor, and what I'll do is I'll switch from model to the sheet metal workspace. And inside here, you'll notice that our tools kind of change a little bit. For the majority, most of the tools are here, sketching tools and whatnot. But some of the create stuff is different, and the modify stuff is a little bit different. But we'll get into that. So let's go ahead and start off by making some user parameters, because we're going to make this a parametric design. So I'm going to pull up my my toolbox and type in param for change parameters. Open that. Let's go ahead and make a new one. I'm going to make this the width. Let's go ahead and make it 50 millimeters. And I'll make another one. Let's call this length. This will be 60 millimeters. Let's go ahead and change that 50 to 60 because I actually want them to be the same on the width and the length. So let's go ahead and add another one, make it height. This will be, let's say 30 because it's a little bit smaller, so it's like half the size. That's okay. Now we can start sketching out our box, right? So I'm going to use the sketch tool, and I'm going to draw on this flat plane here, this kind of floor plane. So I can look at it from the top using my view cube, and then I'll use the rectangle tool using the hotkey R, and then I'm just going to drag this out, and I'll just make it like that. I haven't assigned any dimensions to it, so let's go ahead and do that. I'll make a dimension for this guy up here. Let's make this the length, and then this right here will be the width, this guy, right there. So let's make that width, and that should be 60 by 60. And now we can hit stop sketch. All right, so now what we want to do is we actually want to create this to be our base for our box, right? It's gonna be kind of the floor, the sort of base bottom of our box. So what I'll do is I'll hit under create, you got the Flange tool. We're gonna be using Flange a whole bunch, so get used to it. Instead of extruding, you can extrude, but the Flange is what's gonna kind of start our box here. So I'm gonna use the Flange tool, and this is gonna extrude it out because I already have the profile selected. If you didn't, it would look like this. So you gotta hit the little plus button and then select your profile, which is our little rectangle here. All right, so the next thing I'm going to do is I actually want to hit OK, and that's our base. But what we want to do is by default, you may have to modify your sheet metal rules. So under the modify menu, drop down, we have something called sheet metal rules, and this lets us set how thick we want our material and how much of a bend we want in our material. So I'm going to hit the steel right here and then hit the little pencil icon to edit it. I've already went ahead and updated this. I'm actually going to change this to chipboard. And my chipboard is 0.8 millimeters thick, and I have a K factor of 0. This is kind of saying how much of the material we're going to stretch. Since we're using paper, a chipboard, it doesn't really stretch, it tears, so we're going to put 0 for the K factor. Another thing we want to do is drop down the bend conditions. I want to drop down the bend radius to 0.2 millimeters, because that's a good kind of radius for our bends, but we do need one. Normally it's set a little bit higher than that, but we don't need it to be so high, so I brought it down to 0.2. And all these numbers will change depending on the type of material that you're working with. But in this case, it's chipboard, 0.8 millimeters. Let's hit save. Close that out. And another thing I like to do is I kind of like to make this look like the material. So I'll bring up my appearance window using the hotkey A. That'll bring up the appearance window. And in the library, I like to just search for board. Hopefully I get something. I get this MDF board, so I'll just drag that into the thing. It looks a little bit scaled up, so I can right click on that material. And then I can mess with the scale. So I'm going to actually change the scale from 50 to 40. And you'll see that that texture is a little bit more smaller, scaled down, and it just looks a little bit better. So, okay, now I can close that out. So now we got our base, and what else I want to do is actually talk about making side walls using the flange tool inside of sheet metal's environment. So here's what we'll do. Let's go ahead and bring up our flange tool, and what we're going to do is we're going to select the 4 edges, the 4 top edges on the top surface of our base. So it's this one, and then these 2 over here. So this one and this one. So what I'm going to do is I'm going to start bringing these up. And what I want you to focus on is take a look at the corners. What's going on is with when you flange out edges on the sides, and you have some that kind of are adjacent to each other, you have a little bit of something here called the bend relief. So this little geometry here gets added, this little corner gets added because it's a way for this material, the sheet metal in this case, well, in most cases, sheet metal would need a little bit of relief here in order to actually do this shape. So you can see here as I stretch it out, you'll see that this is apparent in all 4 corners. So what you can do is you can change the pen position to be adjacent. And what that'll do is I'll just kind of bring it out. But in this case, it's still going to give us that little bit of, corner here. So what we can do is we can play around with these until we get one. I don't think it's actually going to work because we're doing all 4 corners. So what we're going to do is we can turn off the miter option, and that'll bring these edges really close together. This is just an example to kind of show, to be aware that there is something like that. And when you're cutting something using a vinyl cutter, you kind of want to be aware of those little corners. So again, if I leave the miter option on, you get that little bend relief there. If you turn it off, it kind of goes away. So I'll have these set out on the inside. And actually what I'm going to do is I'm actually going to delete some of these edges here. Looking at the view cube, I kind of want the front to be our area where we have that tab insert. So I want this surface here, the front. I want this surface this side rather to be the cover, sort of the opening tab here. So I want these to be the sidewall. So I'm going to get rid of this one. I'm going to deselect this guy and the one in the back there, just like that. So now I have 2 side edges, and I want to change the height to our height parameter. Okay, so now if you look at our edge, you'll see that it's nice and flat there, and that's kind of what we want. All right, so I'll hit OK on that. And again, the bend position is set to the inside. If we ever need to change it as we're kind of creating our flaps and folds, we can always go back in here and change this. So for now, I'm going to leave it on inside. So I'll hit OK. All right, next what I want to do is I want to create sort of these side flaps that will kind of hold the side walls together. So I'll just kind of use the flange tool to show you which sides I want. So I want this edge here, and then the opposite edge there. And then also on the other side, we'll select these guys here. You don't have to hold down Shift, which is nice. It just kind of appends it to the flange list. So I have those 4 edges here. So they're all listed here, and you can kind of cycle through them. And then what I'll do is I'll add a height. I kind of want it to be the height divided by 2, which should give us like 20 or 15 rather, because our height is 30. So now you got these flaps, and you'll see what it's doing. So if I look at it from the side, you'll notice that the flange tool is smart enough to not weld this bottom side with the base, which is really nice. If you look at it from this side over here, same thing. Now, if we rotate and take a look at it from this side, you're going to see something a little bit interesting, is that we have a little bit of edge here that's actually protruding out, and it's kind of flush with our surface that's creating our kind of side flaps. So you see there's a little bit of relief here, which is actually good. We actually want this, because if we were to set this on the outside, you can see the flaps actually start going on the outside of this. And if we turn off the miter option, sometimes it'll get rid of this little area here, and other times it won't. But this particular case, we're going to leave it on the inside, and I'll show you why in a second. So now that those are created, it's also going to be the same on this side, because it's kind of symmetrical that way. And now that we have that, I'm going to go ahead and hit OK. Now what I'm going to do is I want to create our I want to create this kind of flange that will come out, that will cover these two flaps, and it'll actually be the top cover for this whole top area, and it'll actually fold down a little bit and then come back in with the insert tab. So let's do that. So I'll grab this edge up here, right? It's on the base, and I'll grab my flange tool and I'll start pulling it out. Looking from it from the side, you'll notice that it's going to kind of try to weld this in, and that's because by default it's setting the bend position to inside, because that's kind of the last option I set. So we can just hit this to outside, but you'll notice here that the wall is actually welding to this, and that's bad. There's not a gap, there's not a clearance between these two edges. So if you use the adjacent option, it'll actually be smart enough to kind of give you that little bit of relief there, that little bit of clearance that you need. And it's really nice that it's working here. If we had this initial bend here, these flanges were coming on the outside, then we probably wouldn't be able to do this, because we wouldn't have that extra bit here on the base to kind of be able to flap over these guys. So let's go ahead and bring this up. Now I could put height here, so let's go ahead and do that for my height, because that's our parameter that we set up. And if we look at it from here, it's nice and flush up there. Because we can use the bend position adjacent, we can create another adjacent face that will kind of cover this. So let's do that. I hit OK, or hit Enter to kind of append that. And now what I can do is I can grab this edge and create another flange. And then again, looking at it from the side here, we can start pulling this in and see if it's going to do what we want it to do. In this case, because we selected adjacent for the last flange, it'll kind of keep that there as the bend position for this flange. So I'm going to bring this out a little bit more. Whoops, I hit right click. I can bring this out a little bit more than I need to, so somewhere around 62, and then we can modify that, because I actually need to bring it back down, so making sure that our flange kind of extends beyond these two flap sidewalls here. So I'll go ahead and hit OK. That gets appended. Now before I kind of drop this down, I actually want to extrude this piece up. So with that edge selected, I'll go ahead and do the flange again. This again, looking at it from the side, I'm going to bring this out, and you'll see it's still set to adjacent, which is good. I'll bring it up. And what I want to do is I kind of want to bring it up, not all the way, maybe about this much. That way I can have a little bit of room here to kind of bring in a tab that will kind of fit in between these two side flaps. So let's hit OK. And what you notice is like, well, if I do the flange, it's going to cut into these guys. So there's a little something special that you can do with the flange. So let's go ahead and do that. So I'll select this edge here, and I'll bring out the flange tool. I'll kind of leave it here since it kind of gives us a little bit more viewing area to kind of play with. So I can bring this in, and you'll see that it is cutting there. But what you can do is you can change this option from full edge to 2 offset, and this will give us 2 handles that we can offset this flange. So if I drag the reference point 1 arrow, you can see immediately what it's doing. We can offset or bring this this sort of flange in, this edge here for this flange. So I'll do the same with the opposite here. And what I want to do is I want to make sure that it kind of comes in a little bit here. I'll actually leave it at 14, which we can add a little bit of extra relief here, a little bit of extra clearance rather. So it's at 14. Let's go ahead and put 14.2, and then for the other offset we'll also type in 14.2, because we know that's the it's symmetrical. We know the other flap is that big. So if we look at it from this angle, we can kind of see that, yep, we still have that 0.2 millimeter clearance between all the edges, which is really nice. But you'll notice that we got that little bit of relief here. I think we can fix that with changing the bend position to outside. No, okay, adjacent was pretty good. Let's go ahead and do something that's different here. We're going to do override rules. So we're going to turn that on, and this allows us to kind of mess with the bend relief override. So let's turn that on, bend relief override. We'll leave the relief shape to straight, and we'll change this relief width to just 0.1. And then for the depth, we'll just put 0. And right away, you can see that with that 0, we kind of got rid of that relief there, because we really don't need it in this case. Because we're cutting this out of paper. If you were cutting this out of sheet metal, you definitely probably want that. But for this material, this chipboard, you don't need it. So it's cool that you have this ability to override the bend reliefs, which is cool. And you have a couple options here to play with too. But for this particular project, we just leave it as straight. So I'll go ahead and hit OK. And now we have our little flap here that gets inserted in between these two sidewalls, which is pretty cool. Now, I've been creating quite a bit of flanges here. You can see I got a handful of them. And one of the important things that I've come to do is to really test this design, test the unfoldability of this design as you kind of create these flanges, especially when you're first starting out. You definitely want to test you want to test unfolding your design before you create too many of these flanges, because if you get a weld somewhere, you'll have to kind of search and find where that weld's coming from. So you can do that by going under the modify, and then there's this unfold. We can select this bottom surface here, and then check this box here. It says unfold all bends, and you get a kind of a preview of your design. If it doesn't unfold, then you have some of the edges are getting welded. That means there's not enough clearance between this. So if you look in this straight down, you can see that all of our folds, all the edges that kind of are intersecting, or not really intersecting, but the folds that are kind of adjacent to each other, they do have this clearance between them. And you'll see it's a very small clearance, but it's definitely necessary in order to be able to unfold it, because if your edges are touching, then it just won't be able to unfold. And you even get this highlight of where the folds are going to be, which is pretty cool. And then if you hit OK, you can actually start modifying this. So we're going to do that, but not. And then after the next fold that we do, after the next flange. So I'm going to go ahead and hit cancel on that, and that'll bring us back to where we were, your folded design. And go ahead and get rid of the layout. Just kind of get a better look of it as I kind of rotate underneath it, and the grid doesn't get in the way. So the next thing I want to do is I want to create that last kind of, well, it's not the last, second to the last flange. It's going to come down here and overlap this whole area here. We're going to have this kind of double reinforced side here, front side. So let's go ahead and select our flange here, and then do a flange. Let's look at it from the side and see if we have enough area to work with. We probably won't. So let's see what happens when we bring this down. Awesome. Looks like the bend position set to adjacent is working in our favor. We have that 0.2 millimeter distance between this. I kind of got lucky in there because I wasn't sure if that extra extrusion there was enough or not. But if it wasn't, we could just go back into that flange and kind of add a 1 millimeter to that or whatever. But in this case, we don't have to worry about that because we got that nice little clearance. So we're going to bring this down. Let's actually bring it down to somewhere near the middle. It doesn't have to go all the way down. I kind of want it right here. I want that tab to be present here. So I'll hit OK. So that looks pretty good. And the next thing I want to do is actually something that will actually make this box much more sturdy, much more structurally sound. And to do that, what we need is some side flaps on these edges here of this top cover to actually go and tuck in between this edge and this edge. And that'll help if you look at boxes around that are assembled out of one piece with no glue, you actually see that they have extra flaps that kind of tuck in between these two flaps. And to get a better visual of inside the box, we can open the bodies folder, right click on it and say opacity control 50. That way you can kind of see where our side folds are. So if you can see, this guy here has those two flaps, same thing with this side. And by having flaps that kind of protrude in the inside and tuck in between these walls, you have this really sturdy box. But in order to do that, we kind of have to modify our flange a little bit here. So let's try to add a flange to this edge here. Again, it needs to tuck in between these two walls, and we don't really have enough clearance here yet, so we'll kind of figure that out as we get there. So with that side selected, I'll go ahead and bring out a flange. And right off the bat, I know I need to change the full edge to 2 offsets. So I'm going to go ahead and start doing that. So I know on this side over here, reference point number 1 needs to come in quite a bit, probably about that much. We'll fine tune it a little bit more. And then on this opposite side, I'll bring this in a little bit more too. So now I can change the height to something like 10 for now. It's hard to see it, so as we kind of go down, you'll see that, yeah, it's actually welding to this face because there's not enough clearance between this. So let's go ahead and play around with our bend position. Let's say we want it on the inside. Right away, you can see that visually that's probably the one we want. And what happens, you'll see that the flange tool is smart enough to kind of push in this side bend over here so that it gives us clearance between these edges. So if we look at this from the top down, you can see that we do have that little clearance going on here. We can even bring this edge back down to where these lines match up. It's a little bit more flush that way. So it's at 1 millimeter. And then over here, it probably needs to be a little bit more because we have that extra flap here. So, but we'll see. So bring this out, and that one's about 2 millimeters going out because we actually have that flange started over here. So it's really, really important to kind of really zoom in and take a look at all of your edges and make sure nothing is touching so that it don't get welded. All right, so now I can actually bring this, I think I like 10 millimeters, that looks pretty good. So what I'll do is I'll go on the opposite side, hold down Command, and then select, oh no, it's not working. So I'll hit the plus button here, and that'll allow me to select this edge here. And the problem here is that it automatically set it to full edge, so it's going beyond the areas that it needs to tuck inside of. So I'll go ahead and change that full edge to 2 offset. And I think this one was -2, and this one will be -1. And that is probably the same. If I select our edge 1, that'll give me the precise numbers. That's 2 and 1. Back over here, 2 and 1. Okay, so that looks good. And again, keep that bend position from the inside because that's what we're tucking in between those two. So I'll hit OK. And Fusion's gonna fix that up, and then that looks pretty good. It's a little bit hard to kind of see exactly how it is because just that opacity control is a little bit hard to see. So I'll turn that off by changing my opacity back to 100, and you'll see that we kind of can modify this a little bit better. So what's going on here is that you do have this edge that's gonna be pushed on the inside, and then you have this little bit of extrusion out here. And then it'll happen to the other side as well because this face here was the full length before we did that sidewall that got tucked in between here. So what we can do is we can use the Extrude tool to bring these in. So I'll select this edge, hit E on my keyboard for the Extrude hotkey command, and then I can just pull this in. So it's probably going to be about 1 millimeter. Yep, looks good. So I hit OK. So now you get this flush edge. And if you wanted this flap to kind of be on the kind of flush with this one, that's okay. But I actually don't want it to be. I just kind of feel like this kind of looks better to me. So I just kind of made that edge flush by extruding that selection. So you'll see here that the flap is a little bit shorter, the lengthwise when it's laid over this fold here. We could also do that to the back here. You'll notice that this is a little bit extruded out. It's probably 1 millimeter as well. Yep, so I can go ahead and select that edge, hit E on my keyboard, -1, hit enter, and that gets flushed. Same, I should have probably held down. So let's go back into that extrusion, and I'll hold down the command key, and then I can select these, and that'll push the whole thing back down. So now we have that nice flush edge there, and we can do the same over here if we need to, which, yeah, we do. So we can select that part, and then these other 2 faces, hold down Shift to select them, to do multiple selections, and then I'll hit E, -1, hit enter, and that gets cut away and nice and flush. Sweet. So the last thing we need to do is I actually want to make a little tab insert, a little tab that protrudes from this. So it's going to be a flange, and then it punches in to a little slot hole on the side here. So let's go ahead and make that slot hole first. So what we can do is we can just select that surface, that face, and then click on create sketch so we can start sketching right on there. So I'll use the R command, the R key, to create a little rectangle, and I don't know exactly how big I want it to be yet, but I know I want this to be in the center of these 2 guys. So what I'll do is I'll look underneath this, and I can grab this edge and then project it in with the letter P, and that projects it in so it's purple. And now what I can do is I can say I want this edge to be in the center of this line here, and also kind of go to that line. So I can do that with one constraint, this guy over here called the midpoint. If I hit midpoint, that pushes it into the center and lines up the 2 edges so that they touch. And if I start dragging this out, you can see that it is indeed in the midpoint. So it's always going to be centered with that line. It's pretty nice. So I can kind of make this as big as I want. I want this slot to be about 2 millimeters. And I'll select this edge and then use the D key to create a dimension. I can make it 2 millimeters tall. And then for the width, I think I'll go for 20, just round that off to 20. So that looks good. And what I'll do is I'll hit stop sketch, and now I can create my hole. So I'll select that as a profile, hit E on my keyboard, -2, hit enter, and that gives us a little cut. And we can kind of see through the box now. Let's kind of cool. So now what I can do is I can use this hole as a reference point to create my flange. So I'm going to grab this edge here, and then I'll create the flange. And before I actually start extruding it out, I need to bring in these edges here. So I'll change my full edge to 2 offset, and then I'll bring these in. I'm not sure how much yet, just enough to kind of be within that hole. So let's bring this one in. Let's see here. So this label's like literally in my way. I can't, there we go. Bring that in. And now I can start bringing this one in, which is the actual flange. And of course we gotta adjust it so that it doesn't cut away. So I actually want the bend position to be on the outside. And then what I'd like to do is turn the override rules on. Let's check the bend relief override, and let's change this relief width to 0.2 and then depth to 0. And then that doesn't look like it fixed it. We still have a little bit of something here. So what we can do is we can say we want this to be adjacent. Maybe that'll work. Looks like adjacent is the one that we want, because it now it got rid of that sort of bend relief. So that's cool. Now we want to make sure that these reference points, these offsets are nice and squared off. So I actually want 0.2 millimeters of clearance between those two. So that's looking good. That was 18.2, I believe. And then this one should be 18.2 as well. So I'll put that 0.2 there. And we only need to make one flange, because that's just one tab. So if we look at it by rotating it, we can make sure that none of the edges are actually touching. I'll hit OK. And if we zoom in here, you can get a better look of it. Let Fusion accept that. There we go. And you can see here that, yeah, there is enough clearance. Even this edge here, the inside edge and that edge have a 0.2 millimeter clearance, which is perfect. So that's looking really good. Now what we can do is we can test unfolding it. So let's go ahead and do unfolds. Select the bottom, check that box, unfold all the bends, and then hit OK. So this will make it so that it's an object here. It's a feature inside of the timeline, so we can always reference that. Also, we can start doing things to this. One of the things that we definitely want to do is we want to create some drafted angles for our sort of our side flaps. So what happens with vinyl cutters is that you kind of want to optimize your edges and your shapes so that your tool isn't dragging the material when it's cutting. And what the tools don't like is like really sharp edges like this. So what we can do is we can add a drafted angle here to kind of relieve that cutting to make a nicer cut. So what I'll do is I'll bring up, actually I need to switch from sheet metals to model. And now we can start doing all the different things, all different tools that we can use to either cut this away or do a draft angle, which I'm going to do. So I'll bring up my sketch toolbox, type in draft, and then select this as my plane, and then this as my face. And now I got this little handle which I can manipulate to kind of create this angle. I actually want it to be 30 degrees going that way. So I'll hit OK, and then we can do the same for this side over here. So again, draft, select this little guy as our plane, and then this as our edge, and then bring it out to 30 degrees, and hit OK. So that's cool. I actually want to do the same to this side, but instead of having to repeat these two, I can just do a mirror. So to do the mirror, I kind of need to create a midpoint construction plane. So I can do that with the construction plane called midpoint plane. I think it's called midplane. There it is. So I'll select this edge and then the opposite edge over here, and then that'll create a construction plane that's in the center of those two selection points. So now I can use the mirror command like that, and then select my faces that I want to mirror. I want to mirror this one and this one over here like that. And then for my mirror plane, it'll be that midplane that we just created, which is this orange guy here. We get a little preview there of what it'll look like, kind of. I'll hit OK. And it did it over there, so that looks great. All right, that looks cool. Another thing we can do is we can round off some of these edges to make this look a little bit more nicer. And that definitely helps the tool. If it's got fillets, rounded edges, it likes that because it kind of relieves the tool a little bit. So I'll do like maybe one or two. Two looks good. And what I'm realizing is this tab looks really, really small. I should probably bring that out. We can either do that in the flange, or we could just extrude this out, whichever is easier for you. I'm probably just going to bring this out myself like that, maybe more, maybe 5. I think I want this to be 10, so it's 7.5. Doesn't really matter. I just want it to be longer. Yeah, it's 10 now. All right, cool. So that works out, and we could even add drafts angles there. Oh, I definitely want to add a fillet to this one. This will definitely help the tool, the cutting tool, when it's cutting and the inside here, because it's such a small feature. So I got this nice rounded edge there, and that's looking pretty good. Now that we have that done, we can refold it. So if we go back over to our sheet metal workspace, we can hit refold faces. And if everything we did was okay, we should have a refolded box. So now you can see that my box has those nice rounded edges here. It has a nice rounded edge here. And it looks like there's a little bit of a problem here. We can just modify this guy here, which is our dimension. Like I say, maybe I want 22 or 21, and that'll just offset a little bit more. There you go, so that you have a little bit more clearance there, because when you added that rounded edge, it kind of started cutting into this little tab here. But I've actually tested this out, and it works pretty well, actually. So now if we wanted to bring this if we wanted to bring our components in here, like a circuit player on Express, we can just right-click on our parts here and bring it in, and then do some extrusions and holes and stuff. But we'll save that for another tutorial. For now, I just wanted to show you guys how the workflow is for creating a box like this. And I'll even share with you guys how to create that flat pattern. So what I'll do is I'll go under Modify, again inside of the sheet metal tools, sheet metal environment. I'll use this guy here. It's right under the unfold. It's called Create Flat Pattern. It'll ask you where do you want your stationary face. Again, we're going to select the bottom because it's kind of like the main base of everything. I'll hit OK. And this will make it so that we can export this out as a DXF. There's a button right here that's conveniently placed. You can't do any modifications here, so, well, you kind of can, I guess. You can do a little bit of, you can do all of them. Well, anyway, we don't have to because we've already done all the things we want. And what I'll do is I'll hit Export DXF. I'll hit OK. And then I'll just save this as like a box toot. And it'll save it as a DXF. I'll turn that hide extension off just so you can see that, yep, it is a DXF. I'll hit save. Now, one of the things you want to do, specifically for a Cricut vinyl cutter, you need a vector editing program to turn it into a vector SVG file. So you could use something like Inkscape. It's a free piece of software, but I know how to use Illustrator and I have access to it. So I'm going to use Illustrator, which is from Adobe. And what I'll do is I'll use Illustrator to convert my DXF into an SVG. I need to kind of clean up some of the well, I don't have to clean up, but you'll see. So box 2, I'll open that. It'll open up in the canvas. Actually, no, this is really, really important. This Dxf Import option asks you what do you want to scale this by, because I guess Illustrator doesn't know that you're using millimeters. So if you look at the scale by 100%, that looks good. The scale factor is 1, and then 1 unit is 1 point. That's incorrect. We actually need to change this to millimeters because we're working with millimeters. And once I do that, you'll see that the number gets kind of offset. So I'm going to change this back to 1. So now I have a scale factor of 1 is equal to 1 millimeter. So that's really, really important. If you don't do that, your thing might not be scaled properly, which is really important because you want to fit precise things. So what's cool about the export as a DXF from Fusion is you get these really nice layers that are named for you. So if you're doing sheet metal, you definitely want to have the bend extent. You want to have the bend layer. But since I'm cutting this out of chipboard material using a vinyl cutter, I actually don't need the bend extent. So instead of having to delete these layers inside of the software for cutting, I can just delete that here and now. And then what you can do is you can actually assign these bend lines or individual lines. So you can assign these as folding lines or lines that will be scored using the vinyl cutter. So that's really cool. And these edges are all nice and clean, so you don't have to worry about cleaning them up. I just wanted to show you how you definitely need to set the scale, and if you're using Adobe Illustrator anyway. And then you can save this out as an SVG. So right here, the option is SVG for the format, and then we would save it out as box toot. And then just use the same, the default profiles that we have here for the SVG. So I'll hit OK. And that's kind of it. Now I do want to show you kind of a quick video of the Cricut style vinyl cutters, and I also have a link here to Amazon where you can see the product listing for these vinyl cutters. Now they're called vinyl cutters, but they can actually cut other things. They can cut fabrics. They can cut chipboard, which is what I'm using. It doesn't necessarily cut cardboard, but it can cut a lot of different types of vinyl in a little bit thicker material. So chipboard. I think foam and other things as well, and they're not too badly priced. Definitely more affordable than a laser cutter or a 3D printer, so that's really cool. And then here's a little bit of the process here. This chipboard again is 0.8 millimeters thick, and the way it works is you secure it to the sticky mat, which is fed into the vinyl cutter. The vinyl cutter has two heads, one for using a pen for pen plotting or scoring, so you can get a scoring pen to create your fold lines, which is really cool. And then the fine tipped blade, which cuts through this thick material. Some of the newer machines have a thick knife blade, which can cut through balsa wood, other types of thin wood, I believe cardboard as well. So that's really cool, especially since you can create this paper box. You can create your own custom templates for your own package designs. Really, really cool when you can do that and prototype it way faster than 3D printing, and probably even CNC milling. Of course, with the laser cutter, you have to worry about ventilation because you're actually vaporizing the material instead of cutting it. But this is really cool. I put together this little project, and here's another clip just to kind of show different designs. So I'm playing with a lot of different designs. Again, this is parametric, so we can change it to fit whatever electronics or whatever product we're working on. So if you're designing maybe packages or something like that, this is absolutely a great skill and a great sort of a great workflow to have. Let me turn that down. But yeah, it cuts pretty quickly, and if you're cutting even harder material, you can just do a couple passes to cut it all the way through. So that's really cool. I think this is a little bit more thicker material, and testing out different types of designs, different types of inserts, all that sort of cool stuff. This is actually a Nintendo Labo button that we remixed and made out of this chipboard. Very, very cool stuff. If you guys have any questions, please drop them in the comments down below. If you have any cool ideas, or if you have any ideas for, I don't know, future tutorials, let me know. I'd love to hear about them. Thank you guys so much for watching, and I will see you guys in the next one.